Okay, so here's another reason. We talked, I guess it would have been on Monday. We talked some more about the methods for factoring trinomials, and we were looking specifically at harder trinomials, where a is not equal to 1, right? We said there were really two ways you could do this. You can use the slip and slide trick, which I don't really like, or you use factoring by grouping. Slip and slide, I think at first glance seems easier for people, and so a lot of times they do that. But here's yet another reason why not to use slip and slide, because it doesn't really apply in situations like this. Okay, when you have multiple variables, it's really hard to make it work. So let's use grouping, but there's a couple different ways we can look at something like this when we're mixing variables, x's and y's like this. This isn't really normal for us, right? Usually we're doing algebra on a function of a single variable. Most of the time in math, like in calculus, that's really what we're doing. The vast majority of the time in calculus is we're doing calculus on functions of a single variable. So this is kind of out there a little bit, but so we need to know how to deal with it. Some algebra that is going to come up later on in your careers. So what do? Well, here's one way to approach this. So one way we could do this, like we're used to seeing things like, if I go back a little bit, let me go back to something like that, right? How did we factor something like this? Well, didn't we always start off with the very first step was to build our template? And we knew those had to be x's. Before we even thought about magic numbers, we knew those had to be x's. And how come? What was our reasoning for that? Or what is some reasoning for that? Okay, because the coefficient of x squared is 1 in this case, right? Everybody get that? So when I reverse the process, and if I were to multiply this thing out, here's the answer. We already know what the answer is, right? What if we wanted to go backwards on this? What if we wanted to start with this thing in factored form and go from there over to there? What would we do? Well, wouldn't you just FOIL it out, right? Wouldn't I just distribute, right? I would distribute the x from the first factor. I would distribute that x to both terms, right? And I would get x squared plus 5x, and then I would distribute the negative 9, and that would give me a minus 9x minus 45. When I add like terms, I would get that, wouldn't I? Okay, but notice that the x squared was determined by just that very first distribution. I didn't have to add any like terms or anything to know that I was going to get an x squared out of this, did I? Just like I knew that the constant I was going to get was going to be provided when I multiplied this constant times that constant. It was the terms in the middle, the O and the I in the FOIL, right? The ones where I ended up with, I had two terms that had an x in each one. Those I had to add the like terms to figure out I was going to get a negative 4x for my middle term, right? Sometimes we call that the cross term because it's the one that's getting, why do we even say it? The cross terms are the ones that we get when we're distributing, but they're not the first or the last. They're the ones that are always going to add, okay? I had to do a little work to find that, but I knew right away that this was going to be an x squared, and that was going to be a negative 45. Those two I knew, right? So the only way I'm going to get an x squared there is if each of these is just a plain old x. Agreed? So I knew what those were right away. Those had to be x's, but now I had to find the right combination of numbers so that I was going to end up with my negative 45 and my negative 4x. Right? The numbers that multiplied, I knew they had to multiply to negative 45 because when I distribute, I've got to get a negative 45. But the cross terms have to also add to negative 4, and hence we have to find those magic numbers. Agreed? Same thing was true for problems like these, right? Now, I know that if I take this problem right here, 2x squared plus 5x plus 3, if I'm going to factor what's that going to look like? What would my template look like? Well, this time I know I'm going to get an x term there and an x term there, but I don't know what the coefficients are going to be yet, right? Anybody get that? And over here I'm going to get some number, and over there I'm going to get some number that multiply to 3, okay? But I don't know what that combination is yet either. But I know my template's going to look something like that, agreed? I have to just go find out what are the numbers that go there, 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 and there. And that's that whole process that we were talking about. Okay, now for a problem like this one we just started. Where is that? Right here. What is the template going to look like? Well, the template's going to look like, you tell me. What part do you know that it's going to be in our answers? We'll build a template and we'll fill in the blanks probably tomorrow. We're going to run out of time. What's going to have to go there? An x term, right? But because I've got an 8x squared, there's going to potentially be some number in front of both of those x's that I've got to find. I'll make it a question mark for now. What's going to go over here? It's going to be some coefficient of some number times y potentially, right? So I'm going to get some number times y plus some number times y. And I have to just figure out what are those 4 missing numbers, agreed? Okay? So then if those are my templates, I can go about this the same way I did before. I just need to find what are the magic numbers that are going to multiply to 8 times negative 3. Okay, we'll finish this up tomorrow.